Let's get started on today's notes over measures of central tendency, and we're going to be focusing on finding the median and the mean of a set of data. So first, let's review what is a measure of central tendency. They're statistical measures that represent the single value of an entire data set. Meaning when I'm looking at a bunch of values, a bunch of numbers, can I find a single value that really represents this set of data? What is it and what does it mean? So this central value tends to be the value other values in the data set distribute around. That's why we call them measures of central tendency. Let's look at example number 1. Bo earned the following 12 grades during his first 3 weeks of school in algebra. Find the mean and the median of the data set, round to the nearest hundredth. So I've got all of these values here. There's 12 values, and they're actually already ordered from least to greatest, which is awesome. If they're not ordered from least to greatest, you need to order them from least to greatest. You don't necessarily need to do that when you're finding the mean. However, if you are a student who struggles with this kind of stuff, I would encourage you to order from least to greatest every time. Just have it be something that you do every time. So they're already ordered from least to greatest, and we want to find the mean of the data. The mean is the sum of all the values in a data set divided by the total number of values. That means I'm going to add all the numbers and divide by however many numbers there are, and there are 12. So how can I remember that? There are a bunch of ways that you can remember this. I like to say, my teacher's so mean, she makes me add and divide. So I'm going to write that down. My teacher's so mean, she makes me add and divide. So what do you have to do? You have to add all the numbers, and then you need to make sure a lot, especially if you're like in middle school doing this, a lot of issues that I see are, okay, you added them all up, but you forgot to divide. So my teacher's so mean, she makes me add and divide. Don't forget to do that. So we're going to add up all the values, and then we're going to divide by the number of values that there are. And in this case, there are 12. When I add up all of these values, because I've already done the math on this, and to just keep this lesson moving, I get 1,063. Now I'm going to take 1,063 and I'm going to divide it by 12, and I get 88.583 repeating, which rounds to approximately 88.58. So there's the mean, 88.58. Now, one of the things that we do, at least in Algebra 1 or 8th grade math perhaps, is when does the mean best describe a data set? The mean best describes a data set when there is no outlier. So there's another vocabulary word. What is an outlier? It's a very high or a very low value, and it can skew your mean. So in this case, we do have an outlier right here. Here's our outlier, and in this case, it is a very low value. Let me write that a little bit neater. There's your outlier, and in this case, it's just a very low value. So, one of the things that I do, if I have, a 9 weeks in school, my students may have 30 grades that I've given. Well, in 9 weeks, that's a lot of grades. I give a lot of assignments. I take grades for those assignments. Let's say, the soccer game ran late, the football game ran late. They had some kind of competition on a couple of nights, and so they scored zeros on some of their assignments. Those zeros can really bring your average down or bring, the mean down. So sometimes what I do in this situation, or every 9 weeks, to alleviate some of those problems, or I'll drop the lowest 2 or 3 grades for every single student that I have, because I understand that sometimes, things just don't get done, and there's a lot of stuff going on and things just don't get done. And hopefully that helps with those kinds of issues, because when we take grades, we're finding the average, right? Every time you get a report card, that's the average, that's the mean for that particular class. So here's the mean. Now, let's look at the median now. And I'm going to switch colors here. What's the median? The median is the middle value. Now, here's really where you need to order from least to greatest. You don't have to do that for the mean, but for the median, you need to order from least to greatest every single time. Or greatest to least, but let's just keep it consistent. Order from least to greatest, and you're going to find the middle value. The median best describes a data set when an outlier exists. So let's write that down. Outliers do not affect the median. And here's why. Those outliers are very high or very low values, which if I'm ordering from least to greatest, those values are on the ends of the data. When I'm finding the middle value, a lot of times what I do, like with middle school, the middle value is cross off your lowest and your highest. Next lowest, next highest, next lowest, next highest, right? And I just keep doing that. And in this case, because there's 12 students and that's an even number, I'm going to have two values in the middle. When I have two values in the middle, I take the mean or the average of those values. Now, when you get into, more upper level math like Algebra 1, which that's what this is for. This lesson is for an Algebra 1 lesson, but you may be in 8th grade or higher looking at this. If I have 12 grades for Bo, that means the lower half of the data is going to be 1, 2, 3, 4, 5, 6 grades, right? There's 6 grades, and the upper half of the data is going to contain 6 grades. Right? So I'm dividing that data in half. And then my two middle grades, whoa, didn't mean to do that. The two middle grades, 92 and 93, I'm going to take the mean of those scores. So 92 plus 93, and then I'm going to divide that by 2, and I get 92.5. There's the median of this data set. Now, let's say you had an even number of grades, like let's say, there were, an odd number of grades, like let's say I had 9 grades for Bo. That means, let's say I had 9 numbers, okay? And where am I going to write this down? I'll write it like down here, this blank space. If I had 9 grades, that means I might have, 4 grades in the lower portion, 4 grades in the upper portion. That's 8 grades. That 9th grade would be right there in the middle, right? That, when I have one number in the middle, that is the median. When I have 2 numbers in the middle, I need to find the mean of those values to find the median. So let's move on to example number 2. Example number 2, and I'm going to go back to blue here, says the frequency table displays the number of students on the roster in each classroom's second period for the local high school. Determine the mean and median of the data set round to the nearest hundredth. Okay, so what are we looking at here? The number of students on the roster, 21 students on the roster. There are 4 classes that have 21 students for second period. 7 classes have 22 students. 14 classes have 23 students. So really what you need to do, take a minute when you're given any kind of graph, which we'll be looking at over the next few days, and tables, make sure you understand what you're looking at here. Okay, so I have the number of students, then I have the number of classes. How many total classes are in the school? Well, that would be 4 plus 7 plus 14 plus 7 plus 6 plus 3 plus 1. That's 42 classes. I'm going to write that down. So 42 classes. If I'm looking for the mean of this data set, if I know that 21 students are in 4 classes during second period, then the total number of students, I could do 21 times 4 plus in 7 classes, there are 22 students each. That's 22 times 7, plus in 14 classes, there are 23 students. So 23 times 14. In 7 classes, there are 24 students. So 24 times 7. In 6 classes, there are 25 students. So 25 times 6. In 3 classes, there's 26 students, so plus 26 times 3. And then in 1 class, there's 75. Whoa, that must be like athletics or something. So plus 75. So when I do this type of math, and I did, 21 times 4 instead of 21 plus 21 plus 21 plus 21 plus 22 plus 22 plus, I'm doing this. What am I finding? I'm finding the total number of students in the school, really, right? For second period. And I'm going to divide that by the total number of classes, which is 42. That's going to give me the mean. Now, I've already done the math on this. If you want to do it yourself, you can pause the video and do that now. But since I've already done it, that's 1,031 students divided into 42 classes, and that's about 24.55 students. What does that mean? That means there are about 24.55 students in each class during second period, right? Which we have to do that because most high schools, that's what you're doing, right? You've got class periods. Second period class. That's the number of students in the second period class, 24.55. Now that's just the mean. Let's look for the median now. Okay, the median, that number's in the middle. I really don't want to list 42 numbers out, right, and find the median. So I would say that there are 42 classes total, which is an even number. That means there would be 21 in each half. 21 in each half. So 21 classes in the lower half, 21 classes in the upper half. So I would say that like 21, that 21st and that 22nd class, like when I'm going through here, would be the median. So let's see. I know that when I'm going through here, the number of classes, 4 classes have 21, right? 7 classes have 22. 4 plus 7, that's 11. 11 plus 14, that's 25. So really my median is going to be right in here, which is 23. 23 is the median. Do you see how I did that? If you struggled with something like that, take another sheet of paper and list out 42 numbers. 21, 21, 21, 21. 22, 22, 22, 22, 22, 22, 22. 23, list it 14 times. 24, list it. I mean, do the work. Do what you got to do to get the answer right. But I know that if I'm looking for, if there's 21 in each half, right? There's 21 in this half, and then there's 21 in this half. I know this 21st number and this 22nd number are my two middle values that I would take the mean of, right? I'd be averaging those two numbers, the 21st and the 22nd number. Well, if in here, gives me the 25th number, then I don't need to average two numbers. Those two numbers in the middle are 23 and 23, which 23 plus 23 divided by 2 is just 23. So there's 23. That's the median. Let's go through and answer these questions. Okay, let me see. Which measure of central tendency best describes the data and why? When you're given a situation where you have an outlier, which this is an outlier, it is a very high value. You have all these classes that have like 21 students, 22, 23, 26, and then you have one that's 75. That's got to be athletics or something, right? That's a very high value. That outlier will really skew your average or your mean. So if you look at these two numbers, we notice that the mean is 24.55 and the median is 23. So the median is actually lower, right? And in this, that 75 right there really pulls that mean up. It really raises it higher when really most of the data is right around here, right? That's where most of the data is. So the median best describes the data because an outlier exists. So when you notice that there's an outlier in your data set, the median is what will be used to best describe the data. So let's write that. The median best describes the data. When you see Y right here and Y, use the word because is your friend, use it. Best describes the data because an outlier exists. Okay, moving on to C. If the high school's goal is to maintain 23 students or less in a class, based on your results from Part A, is it fair to conclude the high school is achieving its goal? Remember, its goal, right, is to maintain 23 students or less in a class. Obviously, there are classes that have more than that, right? There are classes that are going to have more than 23 students in a class, but their goal is to do that. Is it achieving its goal? The median is 23, and that's what we're using as our measure of central tendency because there's an outlier in there. So we can conclude, yes, the high school is achieving its goal. It's obviously not perfect, and that's the thing about statistics. It doesn't have to be perfect, but yes, we can say the high school is achieving its goal. So let's move on to example number 3. In example number 3, it says the school golf team earned the following scores at the last tournament. And then it says determine the mean and the median of the data set. Well, let's determine the mean. When I'm finding the mean, what do I do? When I'm finding the mean, I'm going to add up all the values and divide by however many values there are, which there are 1, 2, 3, 4, 5, 6, 7, 8, 9 values. So I'm going to do 72 plus 74 plus 109 plus 68 plus 75 plus 70 plus 74 plus 72 plus 70, and I'm going to divide that by 9. So if you want to pause the video and do that now, go ahead, because I'm about to give you the answer. When I add up all of these values that are in the numerator, I'm going to get 684. And when I divide that by 9, I get 76. So the mean for this data set is 76. Now let's find the median. What do we do when we're finding the median? Well, in this case, I need to order the values from least to greatest. So my smallest is 68, and then I've got a score of 70, another 70. I've got a 72 and another 72. I've got a 74 and another 74. You know what I did? I have a 72 and a 72, 74, 74. Sorry about that. I have a 75, just one, and then a 109. And what I would do is, you have 9 values here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I would make sure that you've listed out 9 values because it's really easy to make a mistake when you're doing all the arithmetic yourself. So when I'm looking for the median, I have an odd number here, right? So that means when I have an odd number, I'm only going to have one value in the middle of my data. That's really easy. So in this case, there are 9 scores that I'm looking at here. So the lower half is going to have 4 scores. The upper half is going to have 4 scores. And then the median will be right there in the middle. And that median is 72. Is there an outlier in this data set? Do you see an outlier? Yes, 109 is an outlier. All of the values are in the like 70s range, right? And then all of a sudden you have one very high value. So, yes, 109 is a very high value. 109 is a very high value. Oops, sorry. Compared to the rest of the data. Oh gosh, my computer is having a hard time. It's a very high value compared to the rest of the data. And then which measure of central tendency best describes the golf team's scores at the tournament? Well, because an outlier exists, which really best describes the golf team's scores? The median. So I'm going to write the median. Oh, and it's not really working very well. So I'm going to just talk you through this. But the median best describes the golf team's scores at the tournament because an outlier exists. So write that down. The median best describes the golf team's scores at the tournament because an outlier exists. That's when you're going to use the median, if there's an outlier. Now let's move on to samples and populations, and I'm going to talk about this real quick. I might not be writing a ton down because my computer's messing up. But we're going to talk about samples and populations. And what I first want to remind you of is, I don't know if you've ever been to like an ice cream shop or something where they have all these different flavors, all these exotic flavors like cake batter and red velvet and, mint chocolate chips, something like that. But let's say you want to take a sample of one of the ice creams before you order the actual bowl or whatever. They might give you a little bitty plastic spoon or something with a sample of that, right? And so you're given just a really small portion that lets you know, hey, do I like this or not? Should I order it or not? The whole thing. That's a sample in that context. But here's how we use it when we're looking at statistics. When we need data from large populations, we typically gather data from a sample population or a smaller subset of the population that should represent the whole population. It's important to make sure the sample is fair or truly representative of the whole population. So, how do we take a sample when we're gathering data, right? And we say the average American or something like that. I'm not going to poll everybody in America. I might take a sample that should, a smaller number of people take a poll of some sort, how many dogs you have, whatever, that's representative of the whole population. So let's look at, how you might take a fair sample. Although a lot of stuff is done online now, we're going to talk about physical locations to gather data. So in example number 4, it says Elle wants to conduct a poll by selecting people at random to determine which restaurant in town is the local favorite. Where might be a good location for Elle to conduct her poll? Where might be a poor location for Elle to conduct her poll? A good location is going to be a place where a lot of people in town frequent. So your good location is going to be a place where a lot of people in town frequent. Now, where might this be? This might be like the grocery store, for example. Everybody gets groceries, right? So I might set up shop at the grocery store. Or maybe perhaps the gas station or gas stations. Those might be good locations, right? Unless, you're not going to set up shop at a gas station if you're in like the middle of, the city where a lot of people are walking or something like that, right? So you really have to think about where might be a good location for your town. Now, where might be a poor location? A poor location might be And you can discuss. Their answers may vary to this. You might have some great ideas, but a poor location might be in front of a restaurant or a specific group of restaurants, right? Because it's not, you're only getting the people that go to those restaurants. Those might be their favorite, right? So in front of a restaurant, that might not be a good location. In front of a restaurant or specific group of restaurants. So being able to say, hey, how am I going to determine this sample? Where am I going to gather my data? That's really, something that you need to know. In example number 5, which is our last example, it says a nearby college is conducting a poll to find out the percentage of the student body that lives at home. Circle the best location from the following options at which the college should conduct its poll. You've got a movie theater, a football game, a local restaurant, and the center of campus. Does every student go to the movie theater? Does every student go to football games? Does every student go out to eat? I sure didn't whenever, I was in college. I definitely didn't have the money to do that. But where should most all students go? The center of campus. Even students who live at home will be at school. So there's going to be your best location. So even students who live at home will be at school, right? It doesn't matter where you live, you will go to school. You will be at the center of campus. So that concludes your notes over measures of central tendency. This is the first lesson in the statistics unit for Algebra 1. You may be in a different grade level looking at this particular lesson, and that's totally cool. And we really focused on mean and median. We did not do anything about mode, which mode occurs the most. You've probably seen that before, and then the range, which is your highest value minus your lowest value. And we'll get to that in the next few lessons, but I hope it was helpful.